Hi, good morning all of you. This is Vinay. I am studying 3rd BTech Triple E at Ashankara Engineering College in Electrical Machines 3. Today my tech talk topic is synchronous motors. Synchronous motor. A synchronous electric motor is an electric motor in which at steady state the rotation of the shaft is synchronized with frequency of the supply current. The rotation period is exactly equal to an integral number of AC cycles. Synchronous motor contains multiple AC electromagnets on the stator of the motor that create magnetic field which rotates in time with the oscillations of the line current. The rotor, which with permanent magnets of the electromagnet, turns in steps with the stator field and a synchronized rotating magnetic field of any AC motor. A synchronous motor is only consists doubly fed. It is supplied with the independently excited multiples of AC electromagnets on both the rotor and stator. Types of synchronous motors. Synchronous motors fall under the more general category of synchronous machines, which also includes the synchronous generator. The generator action will be observed if the field poles are driven ahead of the resultant air gap flux by the forward motion of the prime mover, and the motor action will observed if the field poles are dragged behind the resultant air gap flux by the retarding torque of a shaft load. There are two major types of synchronous motor depending on how the rotor is magnetized and non-excited and direct current excited. This means non-excited motors and DC current excited. Okay, this is the synchronous motor picture. Those types are non-excited motor. In non-excited motors, the rotor is made of steel at synchronous speed. It rotates in step with the rotating magnetic field of the stator. So it has almost constant magnetic field through it. The external stator field magnetizes the rotor, including the magnetic poles needed to turn it. The rotor made of a high retentivity steel such as cobalt steel. These are manufactured in permanent magnet and reluctance and hysteresis designs. And another one is we have discussed before this DC excited motors. This means direct current excited motors, usually made in a large sizes, larger than about 1 horsepower or 1 kilowatt, and is 1 HP or 1 kilowatt. These motors require direct current, and then this means a DC current supplied to the rotor for excitation. This most straightly forward to supply through the slip rings, but a brushes, AC induction and rectifier arrangement may be also be used. The direct current may supplied from a separate DC source of from DC generator directly connected to the motor shaft. And we have to see the construction of synchronous motor. The principal components of a synchronous motor are the stator and rotor. The stator of synchronous motor and the stator of the induction motor are similar in construction, with the wound rotor synchronous doubly fed electric machine as the exception. And this is the exception between the induction motor and the synchronous motor. The stator frame contains wrapper plate, and the circumferential ribs and key bars are attached to the wrapper plate. To carry the weight of the machine, frame mounts and footings are required. When the field winding is excited by the DC excitation, brushes and slip rings are required to connect the excitation supply. The field winding can also be excited a brushless exciter. Cylindrical and round rotors, also known as the non-salient pole rotor, are used for 6 poles. In some machines, or when a large number of poles are needed, a salient pole rotor is used. The construction of the synchronous motor is similar to that of synchronous alternator. We have to see this. The synchronous motor is similar to the in construction with the synchronous alternator. This is the synchronous motor. The operation of a synchronous motor. The operation of a synchronous motor is due to the interaction of the magnetic fields of the stator and the rotor. This stator winding, which consists of 3-phase winding, it is provided with a 3-phase supply, and the rotor provided with a DC supply. 3-phase stator winding carry 3-phase currents, produce 3-phase rotating magnetic flux. This means 3-phase RMF, and the stator locks in the rotating magnetic field and rotates along with its motor. Once the rotor locks in which the rotating magnetic field, the motor is said to be in synchronization. In a single phase stator winding is possible, but in the case the direction of the rotation is not defined and the machine may be start in the either or in a direction unless prevented from doing so by the starting arrangements. This is the stator and we have to see the rotor. Once the motor is in the operation, the speed of the motor is dependent only on the supply frequency. When the motor's load is increased beyond the breakdown load, the motor falls out of the synchronization. This means when we have to increase the load and beyond the breakdown load, the motor falls and it is thrown from the synchronization, and field winding no longer follows the rotating magnetic field. This is a synchronous motor, and we have to the measurements of the synchronous motor in the this is 8 or 9 centimeters. 9 starting methods. Above the certain size of synchronous motors are not self-starting. Synchronous motors are not self-starting. This property is due to the inertia of the rotor. It cannot instantly follow the rotation of the magnetic field of the stator. Since the synchronous motor produces no inherent average torque at a standstill, it cannot accelerate a synchronous speed without some supplemental mechanism. And motors that are electronically controlled can be accelerated from the zero speed by changing the frequency of the stator current. When a small synchronous motors are commonly used in line powered electric mechanical locks or timers that use the power line frequency to run the gear mechanism at the correct speed. Such small of the inertia of the rotor and its mechanical load is sufficiently small. This is a synchronous motor. Advantage of synchronous motor. We have to see the advantage of synchronous motor. Synchronous motor have the following advantages. This speed is independent of the load. We have to increase in the load or decrease in the load. The speed is constant. The speed is not changing. It is not variable. It is independent from the load. Provide an adequate field current is applied. Accurate control in speed and position using open loop controls. Example, stepper motors. They will hold their position when a DC current is applied to both the stator and rotor windings. Their power factor can be adjusted to unity by using proper field current relative to load, also capacitive power. There are construction allows for increasing electrical efficiency when a low speed is required. They run either at a synchronous speed, also no speed is there. Uses of synchronous motor. We have to see that synchronous motors find applications in all industrial applications where constant speed is necessary. Where constant speed is necessary, the synchronous motor must be used like an industrial purpose. Improving the power factor as a synchronous condensers. We have to see the power factor of the motors are used by synchronizing condensers. Synchronous condensers are used to improving power factor in motors. Electrical power plants almost always use synchronous generators because it is important to keep the frequency constant at which the generator is connected. Low power applications include positioning machines where the high precision is required and robot actuators. Main synchronous motors are used on the electric clocks, record players, and turntables. Thank you so much for this.